The James Webb Space Telescope has made a groundbreaking discovery that defies all current theories about galaxy formation and evolution. Brace yourselves for the mind-blowing revelation that 6 massive galaxies, each with the same mass as our own Milky Way, have been detected by the telescope. These galaxies were formed between 500 million and 700 million years after the Big Bang, which is much earlier than previously thought possible. What's even more surprising is that instead of containing young blue stars as expected, these ancient galaxies are filled with old red stars. Yes, you heard that right. These galaxies contain old red stars that challenge our understanding of how galaxies evolve. This discovery raises more questions than answers. How did the James Webb Space Telescope manage to detect these galaxies? How did these massive galaxies form so soon after the Big Bang? And why do they contain old red stars instead of the young blue stars we would expect to find? Hold on to your hats, folks, because the world of astrophysics has just been rocked by this astonishing discovery. Since its launch, James Webb Space Telescope has captured breathtaking images, showcasing the telescope's remarkable capabilities. These images include detailed views of distant galaxies, star-forming regions, supernova remnants, and planetary nebulae. James Webb Space Telescope has also captured images of celestial objects within our own solar system, including Jupiter's Great Red Spot and Saturn's rings. The 6 massive galaxies that were recently discovered were detected using NIRCam. NIRCam is designed to observe in the near-infrared part of the electromagnetic spectrum, which allows it to see through the dust and gas that can obscure visible light observations. NIRCam has 2 cameras, one for wide-field imaging and one for coronagraphic imaging, which blocks out the light from a star to reveal fainter objects around it. The SEERS program, which obtained the observations of the ancient galaxies, used the wide-field camera to capture images of a small patch of sky known as the Hubble Ultra Deep Field, which the Hubble Space Telescope had already observed. By analyzing the light emitted by the galaxies in the images, astronomers were able to determine that they were viewing them in the universe's infancy, only 500 to 700 million years after the Big Bang. Now we need to answer 2 questions. First, how were such massive galaxies able to form in such a short period after the Big Bang? According to our current understanding of cosmology, galaxies began to form around 150 million years after the Big Bang, from the gas made up mostly of hydrogen and helium that filled the universe at that time. The formation of galaxies involves the gravitational collapse of gas clouds, followed by the formation of stars within these galaxies. Over time, the stars within galaxies undergo a process of nuclear fusion, which produces heavier elements and changes the color of the stars. These 6 massive galaxies were observed to have mature red stars much older than expected, indicating that they had formed much earlier in the universe's history than previously thought. This presents a challenge for current cosmological models, as the density of matter within these galaxies vastly exceeds estimates for this period. The density of normal matter is coming into tension with the amount of dark matter in the halos of these galaxies. Therefore, the discovery of these massive galaxies suggests that our current understanding of cosmology and galaxy formation in the early universe may need significant revision. This may involve rethinking our understanding of the processes that led to the formation of the first galaxies and the role of dark matter in this process. Further research and observations will be needed to understand better the formation and evolution of galaxies in the early universe. The last question we need to answer is why they contain old red stars instead of the young blue stars we expect to find. The answer to this question is not so simple when it comes to the recently discovered massive galaxies. As we know, the stars in a galaxy evolve over time, and their color changes as they age. Younger stars tend to be hotter and bluer, while older stars are cooler and redder. So in general, we would expect to find blue stars in younger galaxies and red stars in older galaxies. However, the 6 massive galaxies that were recently discovered are an anomaly in this sense. Despite being formed less than 1 billion years after the Big Bang, they contain old red stars instead of young blue stars. This is unexpected because, in such young galaxies, there should not have been enough time for massive stars to evolve into red giants and supernovae, which produce the heavier elements that make up red stars. Before scientists start revising our understanding of cosmology to explain the formation of these galaxies so soon after the Big Bang, they need to make sure that the unusual observations are not due to some other phenomena. There are several alternative explanations, but all of them require entirely new concepts. For instance, it is possible that stars in the early universe emitted light in exotic ways because of their lack of heavy elements, which we're not yet accounting for in our models. Alternatively, our current understanding of how stars form locally may not apply to the early universe. In any case, discovering new phenomena that challenge our current understanding is always exciting and opens up new avenues for research. If these galaxies turn out to be something unexpected, they could fundamentally change our understanding of the universe and its formation. If you found this video helpful, please subscribe to my channel. It would mean a lot and help me create more useful content for you. Thanks for watching.